Look alive, people. I know it's end of the day, but anyway, how are you all doing? Having a good time? Enjoying the conference? Okay. You're lying. No. You sound too enthusiastic for the end of a day talk. Cool, cool. And thanks for coming. Thanks for coming to this talk among all the great ones. I'm going to talk about a passwordless future. How many of you are excited for a passwordless future? How many of you are excited to not use passwords anymore? Really? Okay. Cool. So I'm Deepu. I co-chair the JHipster project, Java champion, yada yada. Huge on open source, done a lot of open source work. Polyglot developer, mainly Java, Rust, Go, and TypeScript. Work as a developer advocate for Okta, working on security-related stuff, OAuth 2, all these kind of things. So that's about me. So first things first, right? Why do we even have to go passwordless? We have been using passwords for more than 1,000 years. It has been handy, as long as it worked, sharing Netflix passwords and stuff. That has been handy, right? So why do we have to move away from that, right? Because passwords are a huge problem. So Verizon publishes this report called Data Breach Investigation Report every year. And as per the 2023 report, 65% of all data breaches has something to do with credentials. So social engineering, phishing, credential sniffing, something to do with passwords. And the year before that, that was 70%. So that's a huge chunk of breaches that has something to do with credentials, or a major chunk that at least some of it could have been mitigated if we were not using passwords. I don't think it's a technology issue, it's a human problem. I don't think we are evolved as a species to use passwords properly, right? Because it expects us to remember things, not to share things, not to reuse things, and we have, over a millennia, has shown that we are not good at any of these. We are not reliable. We are always the weakest link, right? So trusting us humans with something like a password, which is knowledge-based, is not a good idea, right? And this issue, you might think that, it's not a huge issue. I use a password manager. What's the big deal, right? But how many of you know somebody outside of the tech sector who is security savvy, who is going and using password managers, who is making sure they're not reusing passwords and stuff like that? Most people don't, right? So this is a bigger issue for the common folks than the tech sector folks. So let's dissect this a bit. So there are a lot of issues with password, but the number one problem is that passwords are knowledge-based. It relies on something you know, which is problematic, right? Because it makes remembering passwords a hassle and also securing them a hassle. If you want a complex password, they're hard to remember. If you want simple, if you create simple passwords, then they're easier to guess. So there's always trade-offs. And there are just too many services these days to create and remember unique passwords, right? So, of course, as people in the tech industry, we use password managers, we know best practices, we kind of work around these issues. But again, people outside of the tech bubble, they don't have a lot of options. Nobody's going to use LastPass or Bitwarden outside of our bubble, right? They might use maybe the built-in password managers on Chrome or whatever browsers, but that's all. Even that, if they are prompted and if someone else sets them up or something like that. Some people, yes, of course, there are tech-savvy people who might be doing it, but not everyone. And the people who are not doing is a huge chunk compared to people who are, doing best practices. Also, social engineering. It's extremely easy to social engineer people. There have been big data breach incidents where the people involved were like 14, 15-year-olds who were social engineering people to get passwords and so on. It's not that hard. There is a popular video on YouTube where this lady demonstrates social engineering a telecom company. They just play the sound of a baby crying and throw some emotional, manipulative things at them, and they were ready to give up the password or reset the password. So not that hard. So again, social engineering works because passwords are knowledge-based. Another issue with passwords are they are phishable, right? Phishing is a huge issue, right? A lot of folks fall victim for phishing. We might escape, but a lot of people do. How many of you have gone to a phishing website and realized that something is wrong? How many of you have actually entered your credentials there? No shame in that, it can happen. Some of these phishing attacks are so cleverly orchestrated that it will be hard to guess that they were not the real page. With websites where they replace the O with 0, for example, so even the domain looks the same. So there are very clever phishing attacks out there. Another issue with passwords being password is remote replay. So someone can access your account from another continent, and if you don't have some sort of alerts or second-factor authentication setup, you wouldn't even know that someone accessed your account. How many of you know someone who got their, let's say, social media account hacked? Yeah, I know a bunch of people who got their Facebook accounts hacked because they entered their credentials into a phishing website and they didn't have any sort of 2FA, right? And most people outside of the tech, they wouldn't set up second-factor authentication unless they are forced to. Nobody's going out of their way to do that. So most people in the world, they don't have 2FAs for most of their stuff. Maybe for their banks because they force them to, nothing else. Another issue with password is data breaches, right? So for a hacker, your website or your application is attractive only because you're storing sensitive information. And one of the sensitive information is passwords. Others like credit cards and these kind of medical info, these kind of things. But most websites storing passwords are a target because there is a huge market for stolen passwords on the internet. There are you can buy a database of passwords and credentials on the internet. So there's a huge market for that. So it makes your application a target because we are storing passwords. So what if we can get rid of that and we don't have to store any passwords? So that makes our server less attractive, right, for these kind of breaches. Another issue is passwords are reusable and shareable. How many of you reuse passwords? Yeah, I do. I mean, there is only enough number of complex passwords one can remember. I mean, I think I can remember maybe like 3 complex passwords. More than that is like, I mean, I rely on my password manager, of course, but there are some instances where you have to, like, for example, some banks or the government agency who go out of their way to make it impossible to do like a copy paste or like, a password manager on their thing. So you would end up, they actually end up reducing the security because they do these kind of stupid things, right? Another issue with password is on the server side. For us folks who are building systems, right? Because passwords are so sensitive, we have to do extra work. We have to encrypt them. We have to do all this sorting, hashing, and all these things for passwords. We have to build second-factor or multi-factor authentication flows to secure it further. We have to additionally secure our applications to make sure they are not breachable. We have to create recovery flows, reset flows, a lot of these things. Do you know a password reset costs around $70 to $100 for each reset, the overall cost. If you divide the effort that you spent implementing these things and the effort of people involved, maintenance effort and all these things. So overall, passwords really bad, right? Obvious solution for that would be to go passwordless, right? But we have been doing some sort of passwordless for quite some time, right? We have biometrics, which is kind of passwordless. Most of the times you do have an initial password to go in and then it is biometric, but still, right, to an extent. There are services that uses a magic link instead of password. They send you a link by email, you go there and you click to log in instead of that. Then some services send you one-time passwords over SMS or something. And then there are services that would send a push notification asking you to authenticate and stuff. But none of these help to reduce the problems that we have with passwords, because even these solutions are phishable. These solutions are remotely breachable. Even with these solutions, there can be social engineering and all these things. So it might have helped in some specific cases, but it didn't help overall. Right? So this is where Passkeys come into the picture. So in my opinion, a passwordless future that we all really want and we all hope for is Passkeys. So Passkeys are nothing but a pair of mathematically linked keys, which is a pair of public keys. So they can be used for authentication. I'll go into details of that. So you probably encountered Passkeys already. How many of you have set up a passkey? Cool. GitHub? LinkedIn. Cool. And how many of you got the prompt from GitHub to set up a passkeys? Cool. So Okay, I thought the rollout was finished. Anyway, so more services, so GitHub, Google, LinkedIn, Facebook, a lot of services are already offering Passkey support. So if you haven't done so, please go check it out. Set up Passkeys, you'll thank me later. It's seamless, it's more secure, it's more convenient to use. So before we dive deep into Passkeys and see what Passkeys are, we need to understand some of the basic technologies that makes this possible. So I'm going to do like a crash course of the most important ones. Let's start with public key cryptography. So public key cryptography, they are nothing but a pair of mathematically linked keys which can prove that they are uniquely belonging to each other, right? So the private key, of course, is private. The owner of the key pair needs to keep that private key secure. The public key, of course, is public. You can put that in your social media profile or you can share them out, no problem, right? So public key cryptography can be used for two purposes. Number one, you probably all are familiar with encryption, right? So we use the same public key pair for encryption. If you have someone's public key, you can encrypt a piece of data using that, and you can send it over to the person holding the private key. And only that private key can decrypt the data. So that is how encryption works, right? Another use case is digital signatures. So if you have a key pair, you can use your private key to sign a particular set of data, and you can send it over to someone. And anyone having your public key can verify that this indeed came from you, because only that private key could have signed the data. This is how digital signatures work. This is how you are using PDF signatures and stuff. So a PDF signature is more trustworthy than your actual signature because it uses cryptography. It is impossible to fake that. Next piece of the puzzle is an authenticator. An authenticator is a hardware or software device which can create public key pairs and which can store them. How many of you used an authenticator? Cool. It's a very security-minded crowd here. Nice. So there are two types of authenticators. Right? So we have something called platform authenticators. These are authenticators which are built into a device. You cannot remove them from a device. So device in the sense a laptop or smartphone, whatever device, right? Which holds this piece of hardware, you cannot remove that. Examples, Touch ID, Face ID, your smartphones, Windows Hello, many more, right? So these are platform authenticators. Then we have roaming authenticators. These are removable devices that you attach to your PC or your smartphone via USB, Bluetooth, or NFC. So examples are YubiKey, Google Titan. Again, your smartphone can act as both platform authenticator and as a roaming authenticator. How many of you have a YubiKey? Okay. How many of you? How many of you have used a YubiKey? Like, cool. So I have this YubiKey with a fingerprint sensor. They have many models. They have a tiny one called Nano. They have ones without fingerprint sensors. So these are considered gold standard of security because of the way how they work. Right? So I'll get into a bit more details of that. But these are authenticators. They make passkeys possible. So another piece of the puzzle is called FIDO. So FIDO stands for Fast Identity Online. So it's a security standard from global alliance of security experts, industry leaders, and big companies. It's called FIDO Alliance. So they have this aim that they want to get rid of passwords and they want to make internet a safer place using cryptography. So that's their goal, and they come up with certain standards. And the standard that we are using for web authentication or passkeys is called FIDO2. So FIDO2, again, consists of two other standards. So it's made up of web authentication standard or web authn. How many of you are familiar with web authn? Web authentication? Okay, good. I have some explanations. Another standard which is part of FIDO2 is Client to Authenticator Protocol, or CTAP. So let's go and break them down. So web authentication is a W3C standard. So it provides a set of JavaScript APIs which you can use to communicate with authenticators, platform authenticators and roaming authenticators. That is what web authentication is. Just two main methods and some utilities. Underneath, web authentication uses a browser's credential management API, or in case of smartphone, the platform's credential management APIs. So it works with whichever platform they are using, and the platforms, they make sure all of them support web authentication. I think all major platforms today supports web authentication. So web authentication has three main components. So authenticator, we saw what an authenticator is. So an authenticator in the scheme of web authentication is responsible for storing private keys and some metadata. Then we have a relaying party. A relaying party is nothing but the server which requires authentication. So it can be your own server in case you're implementing your own solution, or an identity provider if you're using an OAuth 2 service like Auth0 or Okta or whatever. And the relaying party is responsible for storing public keys and any other metadata like usernames, credential IDs, and stuff like that. The third part of the architecture is the client. The client consists of your browser and the user. So the user is there just for providing consent, because Passkeys flow always requires consent. We'll see that later. So the user is there for interaction. It is optional. In some cases, the user may not have to interact, but in most cases, the user have to provide consent. And your browser is responsible for sending data between an authenticator and the relaying party. So it just relays data back and forth between them. And the next one is client to authenticator protocol. So this is the protocol that we use to communicate with roaming authenticators, specifically roaming authenticators, via USB, NFC, and Bluetooth. So the client platform, as in your browser, can already talk to the platform in case it wants to communicate with the platform authenticator. So let's say if you're on Chrome on Mac OS, right? So Chrome will talk to the credential management API of the browser, and the browser will talk to the Mac OS's platform authentication API to talk to the Touch ID TPM. But in case of roaming authenticators, we need a standard which is cross-platform and uniform everywhere. So we have CTAP2, and the browser will invoke CTAP2 via WebAuthn to talk to roaming authenticators. Can be USB, can be NFC, and sometimes Bluetooth. I will come to that Bluetooth part later. So in short, with all this, Passkeys are nothing but discoverable passwordless FIDO credentials. That's the technical name, but it's a mouthful, so nobody uses that. So Passkeys kind of became the noun used for this. So let's dive a bit more. So there are two variants of Passkeys. So we have synced Passkeys. So synced Passkeys have a better user experience, right? So in case of sync Passkeys, the private key that your authenticator generates, right? So the key pair that your authenticator creates, the private key, it is stored on the authenticator, but also gets end-to-end encrypted and synced to the platform's cloud. For example, if you're on Mac OS and you go and create a passkey, so the Apple Enclave, I believe it is called, the TPM that Apple uses, it creates a set of keys. It stores the private key locally, and Apple takes that private key, end-to-end encrypts it using your iCloud password, and then it syncs that to iCloud keychain. So all your private keys get synced to iCloud keychain. The same happens if you're using Google Chrome, for example. Google will do the same and syncs your private keys to Google Password Manager. Similarly, if you're using, let's say, Bitwarden or LastPass or any other password manager that supports passkeys, they can also do the same. They can also take your private keys, encrypt it, and store it in your whatever password manager vault that you have. So that is synced passkeys. And because of that, we have better usability because everything is seamless. You don't have to go register each device every time. You only need to enroll once in any device you want, and you will be able to use that private key in all the devices connected to that particular platform. For example, if you add, let's say, iPhone to your Apple ID, the private keys that you created in your macOS will automatically get synced to your iPhone. So the next time you go to the same website on your iPhone, you will have that private key there already. So you don't have to register again or anything. So that's the seamless syncing aspect. Another advantage of synced passkeys is that as an implementer on our side, like as application developers, right, we don't have to implement any recovery for synced passkeys. Recovery, all this aspect is taken care of by the platform. In case you lose your device where you created your passkey, right, your private key, that's not a problem because Apple Keychain already has that, right? So when you add a new device to the same ID, that gets synced to that new device. So you are not losing your private keys. That's the advantage. But the downside of sync passkeys is that theoretically it is slightly less secure because your private keys are being stored in a cloud. So theoretically can be breached, even though it is end-to-end encrypted with your credentials and everything, theoretically can be breached. So theoretically it is slightly less secure. The next type of passkey that we have is called hardware-bound or device-bound passkeys. So these are considered golden standard of security because the private key is stored only on that device. Nothing gets sent anywhere, nothing gets synced to the cloud or anything. This is mostly applicable for roaming authenticators because they have the capability to store keys and it will only store on that particular key. But also, for example, Windows Hello is also kind of device bound for now. I believe they're working on making it synced. But for now, there are devices which can be used as device-bound passkeys. The private key is stored locally. But that means we have the opposite of sync, right? It is not as convenient. Because, for example, if I'm using a YubiKey for device-bound passkeys, I have my private keys here, right? So that means I have to carry this around every time I need to log into the website. So if I lose this, it's gone. It's not synced anywhere. It's not backed up. It's gone. So which means each device I use needs to be enrolled, no recovery or backup. But it is the most secure option because in order to crack this, somebody has to physically get this device from you and a second factor. And these keys are always multi-factor. I'll come to that a bit more because especially for a passkey implementation, if you're using a roaming authenticator, you have to have the item, which is one factor, and you have to provide, let's say in this case, a thumbprint, and in some cases, a PIN or whatever that supports, right? Same for platform authenticators. It is always two-factor. So it's always a trade-off between security and usability. There are use cases for both. Sync passkeys is meant for the masses because general public is not going to care about slightly more security. They are not going to bother to get like a YubiKey or something like that, right? So that's not going to happen. So sync passkeys is for the masses because most people will have an authenticator built into their device, like a Touch ID or Face ID or whatever. And device-bound passkeys are meant for technical folks. People in the IT industry, sysadmins, and people who are really security-minded, they can go for device-bound passkeys. So let's see how the flows work. So there are two flows when it comes to, is it a count down or count up? Okay. So there are two flows when it comes to passkeys. We have a registration flow and we have a login flow. Let's see how the registration flow works. So for the registration flow, the user would go to the website, let's say a cool site, and click on the register button. So the website's client-side implementation will talk to the server, which is a relaying party, and ask for a challenge. The server will send like a random piece of data as a challenge, and in most practical cases, that's going to be like a byte 64 string, random string or something like that. So the client got the challenge, then the client triggers the web authentication API, the .create method of the web authentication API, and passes some metadata like username they want to use, the challenge, the domain of the website, and all these things are passed. So web authentication, when it is triggered, it looks for the authenticators in that system. So if it finds multiple authenticator, it will prompt you to select one. If not, it will go with whatever is default. And as soon as the user provides consent by like fingerprint or by entering a PIN or something like that, the authenticator will create a new public key pair. So this new public key pair, the private key is stored on the authenticator. So these are asymmetric private public key pairs, right? The public key is not stored on the device, only the private key is stored. And in case of the synced version, right? In case of synced passkeys, there is an additional step that your, let's say, Apple or Google or Bitwarden, it will take that key, encrypt it, and sync it to the cloud. So that is an additional step only for synced passkey. But for everything else, it just continues. So once the key pair is created, the authenticator also creates an object called attestation response. So this attestation response will include the public key of the pair, unique credential ID for this, and some other metadata like the certificates used, what kind of authenticator was used, all these metadata. It will put all that in an attestation object and pass it back to your client-side implementation. So your client-side implementation will pass it back to your server, which is a relaying party. So the relaying party will validate this response to make sure it uses the same challenge that it issued. It has a valid SHA and all these things. It can verify that. And once verification is completed, the user is registered with the public key. Here, you don't have to do any additional security. Like, you don't have to encrypt the public key. You don't have to make any additional security measures when saving this. This is public data, so you can just save it as it is. And the registration is complete, right? So now let's say I'm registered. I want to go and log in, right? So we go to the login flow. Looks extremely similar to the registration flow. The user begins login, goes to the website, clicks on the login button. The client-side implementation will talk to the server, ask for a challenge, gets a random challenge. It will now initiate the .get method of the web authentication API. Earlier it was create method. So there is just these two methods. It will pass the challenge to the method. Again, web authentication looks for authenticator. It finds an authenticator. The user provides consent. And as soon as consent is obtained, the authenticator looks for every key that is associated with this particular domain. Because when it created the keys, the keys are bound to the domain and the user. So now it looks for the keys that is available for this particular domain. The keys are surfaced, and the user can select. If they have multiple, they can select. If not, they will go with the default one. So once the key is selected, the authenticator. So this is an additional step in case of sync passkey and you're using a new device, because then the private key is synced from the cloud here. So it's an additional step for sync. So as soon as the user chooses passkey, the authenticator, again, this is all being done by the authenticator. For example, if you're using a YubiKey, it is done by that YubiKey, or the Apple's TPM chip, or your laptop's TPM, or your phone's TPM chip. So the authenticator signs the challenge that it obtained using the private key and creates an object called assertion object. Earlier it was attestation because you're registering, you're attesting. Now you're validating. So you're asserting, it creates an assertion object, it puts in the signed challenge, it adds some metadata and all those things and passes back to your client side. Your client side sends that back to your server. Now, the server already has the public key of that user, right? And now it got this object which has a signed challenge, and server already knows the challenge that it issued. So what it does is it compares these two with the public key and to make sure that they match. And if they match, that means whoever did the flow has the private key belonging to that public key. So it is same as digital signatures. So the user can be trusted because they possess the private key. So you are logged in. So this is how the entire flow works. And this has nothing to do with OAuth 2, OIDC or nothing. This is regardless of what kind of authentication flow you use, these steps are the same. So you can replace your password-based flow with this or your OAuth 2-based flow with this. Doesn't matter. It only replaces the password aspect of things. So that's both flows for passkeys. So now that we understood how passkeys work, right? Let's see how it solves the issues that we saw, because we are trying to move to passkeys because we have issues with passwords, right? I think hope you remember the issues that we had. So passwords are knowledge based, right? But passkeys are not knowledge based. They are discoverable credentials which you possess. So they are something you have instead of something you know, which is always much more secure, because something you know can be, someone can get hold of that and use it without your knowledge. But this, if someone gets hold of your key, you would know that. And it's also harder to do that. They are phishing resistant, because if you get a phishing website which looks very similar to your actual website, your authenticator will not surface any keys because the domain doesn't match, because the keys are tied to the domain. So phishing is not going to work. So phishing website will not do any. You cannot even force your way to enter anything here. You cannot, because you cannot get the private keys out of an authenticator unless the domain matches. And remote attack resistant, because you physically have to be present. Either you have to have the key, or you have to be at the device where you have the private keys. So remote attack is out of the question. They are breach resistant because we are not saving any sensitive information. We are only saving public keys, which is useless for someone hacking in. And by design, they are not reusable because for every service you register, it is going to create a unique private public key pair. It's never going to reuse anything. And it is also not shareable with a star. Technically not shareable, but Apple somehow made it shareable. I think in Apple you can airdrop a passkey, which kind of beats the purpose, but yeah, shareable with a star, not shareable with a star. And the last piece is password management, right? So passkeys make that a little bit more simpler for us. So in case of sync passkeys, we don't need any recovery mechanism. Password reset is out of the question because you don't have to reset these things unless your company wants you to have this rotation thing, which is kind of pointless in case of passkeys. Other than that, you don't have to do any reset things because you're not going to forget these. If you forget the device or something, then you're screwed. So there's no forgetting and resetting aspect. And for sync passkeys, we don't need recovery flows because the platform like Apple or Google will provide that. But in case you're supporting device-bound passkeys, you would still need a recovery flow because device-bound passkeys don't sync the private keys. So you need some sort of recovery flow there. But still easier. We don't need encryptions and stuff for saving data. We don't need multi-factor authentication. So if you're using passkeys, you don't need multi-factor authentication. Because as I mentioned, passkeys are two-factor by default. So you're already giving one factor being you possessing the device and the second factor being your thumbprint or a pin or something. So there's already two factors. So you don't need multi-factor authentication technically. So if we start plotting this on a security versus usability scale, right? So passwords are of course the least secure, but it is very high on usability because it is convenient to use. Then we have a password plus some sort of conditional multi-factor authentication, which is slightly more secure, but slightly less convenient. Then we have password plus mandatory SMS or OTP-based two-factor authentication. Again, slightly more secure because it is mandatory 2FA, but less convenient because you have to go take another device and stuff like that. Then we have social login or to social login, which is much more secure because we are relying on the security of the OAuth 2 provider. Like if you're logging in with Google, we are relying on the security provided by Google or whatever service you're using. And the assumption is that their implementation is much more secure than our assumptions. It is also much more usable because it is quite seamless. You just click on login with Google, and if probably you're already logged in with Google, so you just go into the website without much hassle. Then we have sync passkeys, which is much more secure than OAuth 2 social login, but also slightly more usable because it is also seamless. You don't have to go fetch another device or something. You have your authenticator in your device already. It's synced everywhere you log in and etc. Then we have a password plus a FIDO MFA. FIDO MFA is the same technology that is used for passkeys, which can also be used to implement multi-factor authentication. So if you're using password plus FIDO-based multi-factor authentication, it is considered as secure as sync passkeys, but less on the usability scale because again, you have to do two factors. And finally, we have device-bound passkeys, which are considered the golden standard for security because of how it works. But again, not that usable because you have to carry around these keys and stuff. I, for example, always forget to carry this sometimes, and suddenly if I want to log into a website where I use this, then I'm like, oh shit, I didn't bring that. So there is a usability issue there. I mean, not everything is hunky-dory there. We have challenges, like with every standard. Web authentication being a W3C standard, you all know how W3C standards work, right? We are going to have inconsistencies in implementation between browsers. We are going to have some inconsistency between operating systems, for example. So not everybody is not going to play nice with everyone. So it's going to have that kind of discrepancies and stuff because we are relying on browsers and operating systems for this. Then there is a valid privacy concern of over-reliance on cloud providers. Like, do you want all your private keys also to be stored by Google? I mean, probably if you're already storing all your passwords with Google, then probably not a big deal. But if not, then there is a privacy concern there. You might have issues in enterprises where, let's say, if they're not allowing Google or iCloud or something like that, then you will have issues creating sync passkeys there. Of course, you can do device-bound passkeys in all these cases because it doesn't rely on any cloud or anything. And most probably for very secure-minded use cases or enterprises, that is what they would adopt, device-bound passkeys. but there are those concerns. And finally, for device-bound passkeys, we still need a recovery mechanism. We can get rid of that for sync passkeys, but in case you want to support device-bound passkeys, then we still need a recovery mechanism because there's no backup or anything. So let's see how passkeys work. I'm going to show you two examples. I normally live code this, but yeah, I don't think there is enough time to live code and to show two demos. I'm just going to. Is it visible at the back? Okay, anyway, I don't think this matters much because I'm not going to live code. I forgot. I'm just going to start the server and show you how it works. Not this one. So I have a very simple Spring Boot application. Basically, you can create this application with these 4 or 5 steps. I just ran start.spring.io to create a skeleton. I added a single controller for the slash endpoint, the root endpoint. Then I created an Auth0 account because I work for Auth0. I created an Auth0 OIDC application, and I updated the credentials to my application, and that's it. That's all the steps to create this application. You can look at the GitHub repository if you want, but that's all the steps there. So I'm going to start that. I can barely see my. Do you see my mouse pointer somewhere? It's so difficult to see from here. Okay, I found it. It's here. So I'm going to start this. So first I'm going to show how you can use your mobile phone as an authenticator. So one thing I missed to tell you was that in case you are on a system like me, I'm on Linux, and browsers don't support platform authenticators on Linux. Even though most computers have a TPM chip, Linux supports fingerprint sensors and stuff like that. But still, Chrome or Firefox, they don't support platform authenticators in Linux. So my only option is to either use a YubiKey with device-bound passkeys, or to use my phone as my authenticator. And in that case, I can create sync passkeys, because I'll always use my phone to create the passkey. It is an additional step I need to have my phone, but I can do sync passkeys that way. I'm going to show how that works. So it is called cross-device authentication, and this is where the Bluetooth comes into picture. So to ensure additional security, when you use your phone as the authenticator, the device, let's say in this case I'm using a laptop, right? So my laptop's Bluetooth must be on, and the phone's Bluetooth also must be on. And the laptop ensures that the phone's Bluetooth signal is visible, which means the phone is in a 100-meter vicinity. So it ensures something you have factor with that. So let's go to the website. Am I connected to the internet? Yes. Okay, yeah, just a bit slow. So I'm going to sign up with a new, I'm going to use, I don't have any email validation enabled, so it's fine. So I can create a passkey. Oh, I didn't sacrifice to the demo gods today. So, you know what? I'm not going to waste time on this. I'm going to show you the next one. I'm pretty sure I did something stupid there, as usual. I'm certain I did something stupid there. I'm going to use the other application. So the other application, I'll show what the other application is in a bit, but I'm just going to show you the demo first. Because this doesn't matter. What matters is the demo. So I'm going to, yes. So the browser will give me options, right? So if you go with this option, it gives you a QR code where you can scan that with a mobile phone, and your mobile phone gets synced, and then you can create the passkey on your mobile phone. So and in your mobile phone, you can use whatever, like your password manager or your Apple's ecosystem or Google, whatever. And if you have already logged in, for example, I'm on Chrome, right? And I have an Android phone, so Google already knows that. So it already shows my phone as linked there. So if I choose this and click continue, I'm going to get a pop-up on my, oops, too many things here. I'm going to try that again. I think I took too long. I hope I'm on the same network. Yes. Use my phone. Yes. Yeah, so I'm going to get a pop-up in my phone asking me to create. So it is trying to connect to the device because it is trying to find the Bluetooth signal, and for some weird reason, it is taking quite long. I should have devices couldn't connect. Yeah, I should have done a sacrifice to the demo gods. Okay, not my day, I guess. Come on. Come on, come on. Yeah, okay, it worked. So, and I have already set my phone to use, let's say, I have a Samsung phone. So I use Samsung's, the on-device key, like password manager. So I'm using that. So I created a passkey. It asks for my fingerprint, done, and so they communicated and the passkey is now created. So now the passkey is saved in my Google account. So I can go in any device and where I have my Google account signed into Chrome or an Android phone, and I can use the same passkey. So this is how I would create sync passkeys if I'm on a platform where platform authenticator is not supported. So now I can sign in with the passkey, and it is going to, I'm not going to select this because it's an older one. I'm going to continue. And I get a prompt to select a passkey here, so I'm going to, yeah, it hasn't synced yet, so I'm going to try again. That's a small annoyance I'm having. I believe that's probably like a Samsung issue, I hope, because I didn't see that in another phones, because it takes 2 tries to get that last one synced or a bit of time. It doesn't come automatically, and it still hasn't come. Let me see if the last one works. The one that I created previously probably won't. Oh, okay, it worked. Okay, so I just used a previous one I created. The one I just created with the test@test.com, it didn't. Oh no, I didn't use that, right? Oh, I used the JHipster one. Oh, okay, that was the right one then. Yes, that was the right one, sir. Thank you. I was thinking of the one that I was using in the other demo. So let me continue where I left. Oh, yeah. So the first demo didn't work. I will look into. Probably I put in the wrong credentials or something somewhere. But anyway, so if you're building Java applications, and if you don't want to use an IDP like Auth0 or like Keycloak or something to take care of your passkeys and stuff, you can roll your own, like how you would roll your own password solution. So you have 2 options in Java. So there is a library called WebAuthn4j, which is 100% compliant with all the standards. It's Kotlin friendly. It is used by Keycloak. It has excellent Spring security support. So you can use this to implement passkeys in your application. Another option is Java WebAuthn Server from Ubico, which again, similar, but I consider WebAuthn4j to be a superior library because it is open source, it's better maintained, and has more options or supports more formats than this one. But you can use either to implement passkeys in your application. So the application that I just demoed is something I built using Spring Boot and WebAuthn4j. Again, very simple application. I created a start.spring.io skeleton. I added a controller, a Spring config, and I integrated WebAuthn4j and configured certain beans for that. So if you want to take a look, you can clone this repo, and you can look at the security config and the default controller there. It's only 2 files that matters, where the implementation is. It's quite simple to implement. It is as simple as how you would implement a password-based system with Spring security, right? It provides most of the things out of the box. You configure certain few beans, and voila. So you'll have passkey support. So this is that application. And if you want to use Spring security natively, passkey support is also coming to Spring security. So it is currently being worked on. Rob Winge is working on Spring security WebAuthn as a separate project. But it will become core Spring security, hopefully with 6.4 in November, hopefully. But yeah, it's in experimental state now. It provides a default registration and login page, so you don't have to implement that yourself. The WebAuthn example that I just showed, I had to implement the login page myself. It doesn't provide that out of the box. Whereas in the Spring security one, it will provide you login pages, registration pages and stuff. So you don't have to do much. You just need to enable passkey support in your Spring security config. That's it. So it's hopefully coming in November. that's kind of it. If you want to learn more, I suggest learnpasskeys.io is an excellent resource where you can see step by step what happens, what data is being created, what data is being sent to the backend, what you are getting from your authenticator. If you want to test out your authenticators and stuff, you can use that as well. It will show you, what data it gets out and all those things. So it's a nice way to visually learn how everything works if you're interested, and other resources for more web authent related stuff. And before I move on to questions, I work for Auth0. So if you want an identity provider, use them because they pay me. And yeah, we have some Spring Boot microservice workshops and stuff. If you want to try them, it's self-paced and everything. Basically, we want you to sign up and try our platform. So that's about it. And I will take questions now. Thank you. No questions? Oh, great.
How do you think general users start to adopt?
Yeah, I think right now we are being kind of like the beta testers as people in the tech world. I believe for adoption in the general public, it's going to take a few more years probably, and a lot more push. There is a lot more push from these bigger companies for Passkeys, but still not at the level of general public yet. And I am seeing a lot more adoption in the tech world, because the first time I did this talk almost a year ago, I asked the question, how many of you use Passkeys or know about Passkeys? And like there were 1 or 2 hands. And yes, last week I asked the same at Spring.io with like I think 500 or 600 people, and like there were a lot of hands. And even today there were a lot of hands on Passkeys users. So I think the adoption is increasing and the awareness is increasing. But the hope is that once the tech world adopts Passkeys, there will be enough data to kind of see what issues we face, because there are issues, right? It's not everything is not smooth now. We have issues like, for example, if you have LastPass installed on your Chrome, it sometimes take over the flow from Chrome. If you want to use Chrome, then it is a bit annoying. So there are these kind of issues currently. So a lot more things needs to be ironed out. But again, we have to, be the path leaders using that and adopting that, and kind of, working out the kinks. And then I think general public will find it easier. And I believe general public will only adopt sync Passkeys. Nobody's going to buy a YubiKey other than sysadmins and people who are forced by their company. Nobody else is going to buy a YubiKey. So it's going to be sync Passkey. So there will be a lot more push for that. And device-bound Passkeys, there are also some work going on in terms of figuring out if we can somehow have a recovery mechanism for that. But yeah, those are currently being worked on. So it will happen, but it's going to take some time. Yeah. Any other questions? Yes.
Yes, in the slide you've shown with the whole path, when you say the private key is associated with a specific this one. Yeah, over there.
I think the previous one, you're talking about this one.
Yeah, it's pretty much
the registration, yeah.
Yeah, when you say it's like that one is for cool site, does it fully rely on what to determine so that we avoid like one site requesting the authentication of another and stuff like that?
Yeah, so it relies on the domain.
Just fully on the domain and having HTTPS, I guess?
Sorry?
On the domain and having HTTPS?
Yeah, I mean, okay, that comes in later, but the first thing is your browser knows the domain, right? So even if you try to pass something else, it's not going to work. It is going to fail saying that the domains doesn't match. So you have to pass the same domain. So, and you cannot force that because browser will figure that out and stop you from continuing with the flow. So yes, the keys are bound to your domain and also to the username that you choose, something like that. So that is how it avoids phishing, right? So the authenticator will only surface things that the browser tells which domain it is requesting. And you don't have a control over how web authentication API is talking to the browsers. That's not exposed to developers or the client-side JavaScript. Client-side JavaScript only gets 2 methods, get create, and some utility methods like seeing if there is an authenticator present and stuff like that. Nothing else is in the control of the JavaScript application. So the web authentication API, your credential management API, platforms, they all work hand in hand to ensure that only valid keys for the domain that you are working on get sent. And in case you are working with iframes and stuff, there are certain options for that. But that's all. So you don't have any control to kind of spoof that or force that. But yeah, it is tied to that.
So I'm guessing like the whole passkey concept in general is fully for just working in a browser, not for supporting anything else? Or?
For now, it is on the browsers, but there is work being done so that you can use the same in Android and iOS, for example, because Android iOS already supports web authentication. That's how I'm getting that pop-up. I didn't install any additional application to use my mobile as an authenticator. I think the same for iOS as well. You don't have to install anything new to use that. The feature is part of the operating system. So it is already there. Yes, there is work being done to make it possible to use in native applications. But the primary focus for now is the web applications because that is the majority. So once that is figured out, native applications will come. But yeah, I think that is already there, worked on. Yes.